Hello everybody, thank you for joining us on our channel. Today I would like to present you our very advanced technology that we call color spectrum, that will be the new word in the world of smart contracts. So smart contracts is a new way to organize computations in the open world, and it really reshaped the IT community, IT world. By the end of 2018 there was about 1 million of smart contracts deployed in blockchains. They are rapidly reshaping the information society. You maybe know such words like Ricardian contract, Austrian contract, that are ways to organize relationships between people in a very new form, the form of executable and objective contracts. ICO, crowdfunding, some kind of governance, we can say that the smart contract is in some sense bringing life to the digital democracy. And maybe there will be many other domains where that will benefit from smart contracts. But with smart contracts, it's not that simple. The situation is rather challenging. The major challenge is the performance of smart contracts. The reason is that modern blockchains, they use smart contracts in very specific way. The smart contracts, they are executed one by one, and the transactions are put into the blockchain. So this picture is a kind of a comic representation of this case. So all the transactions, they are first pulled into the blockchain, and then they're being pushed, being executed one by one by a single node that is building a block. So all the blockchain actually in this point decreases just to one computer. So that makes the contracts by nature very simple. So the simplicity required by the rule that the bigger smart contract is, the longer it is executed, and then it means that the less transactions per second will be available. And people who introduced smart contracts to the world, they use rather exotic language, let's say, like Solidity for Ethereum, or in Cardano network they're going to introduce Bluetooth, and there are many other attempts to introduce languages for smart contracts. This results in few developers in smaller ecosystems, like lack of important tools, difficulties with deployment, with difficulties with debugging and so on. And that's why smart contracts at the moment are not that power software as in other domains we have. And in our spectrum technology, we follow the following design goals. First, we would like to introduce sophisticated business logic to smart contracts and distributed applications. We would like to support efficient execution of thousands of such smart contracts and decentralized applications simultaneously, not one by one, but true parallel high performance execution. And to build efficient ecosystems, rich ecosystems for efficient, rapid development of smart contracts and decentralized applications. If we have a look at the root of the problem, we will see that people are trying to overcome this problem with smart contracts performance in different ways. One of them is, let's make blocks faster. The faster we produce the blocks, the more transactions we pass, the more invocations of smart contracts we can execute. So from 10 minutes in Bitcoin to 1 second in EOS, for instance. Another approach is to produce bigger blocks, like segmentation weakness, off-chain data, or using blocks of gigabyte size. So all of them are like pushing more and more transactions into a single moment, but all of those approaches have an inherent limitation. The performance depends on the time per transaction. The longer time transaction is being executed, the less transactions are because they are executed one by one, one by one. And there is a limit, natural limit, to the TPS, to the performance in terms of transactions per second in any of such solutions. So we need something new. We need another approach to solving the performance problem of smart contracts. And our response to this call is, let's do it all at the same time. Not one, not by a single hand, but multi-handed in many locations. And the overall design principles of a smart contract in color spectrum is that execute first and put the data into blockchain only then. It's opposite to the existing blockchains where you first file data and only then it is being executed. No, execute first and put it into the blockchain. And the core this sketch of technology represents all key components. Terminal nodes, that is mobile phones, wallets, maybe applications, client applications. They operate, they interact with smart contracts that are being deployed in logical runners. This is the component that we call it logical runners through some interface. And then the results of computation that could be made in many parallel threads, parallel processes, or even parallel CPUs are saved to the blockchain. So this architecture potentially results in incredibly high throughput and very sophisticated apps, because here we are not limited into the time. So like EOS, after 30 milliseconds, they kill the smart contract because it is too long. No, it can execute even seconds or minutes, it depends. Do it as long as you need for result. And then the results are being saved to the blockchain for publicity, for openness, for cross-validation, and so on.